Alright, in this video we're going to go over questions 11 through 20 of the June 2014 New York State Algebra Regents exam. Okay, so let's start with question 11. It's asking us, what is the correlation coefficient of the linear fit of the data shown below to the nearest hundredth? Okay, so first question we want to ask ourselves is, what type of correlation is this? We can either have positive correlation, negative correlations, or no correlations. Positive correlations are when you see things looking like they have a positive slope. So positive slopes start low and end high. Negative correlations is if you see the data points look like they have a negative slope. So that's starting high and ending low. And if they have no correlation, then the data points will kind of just be scattered randomly across the coordinate plane. Okay, in this case, what do we see? It looks like this is kind of sloping down. Right? If I had to draw a line that represented kind of the average of all those data points, it would kind of look like this green line I just drew. So this looks like a negative slope. Okay, so if we look at our answer choices, 1 and 2 are both positive, so those are out. Okay, now what exactly is the correlation coefficient? The correlation coefficient just tells us how tight are they on that line of best fit, which is what I just drew. So a correlation of 1 or -1 means they are perfectly correlated, and that means that all the data points will be exactly along that line. Right? The closer the correlation coefficient is to 1, the more likely those, or the tighter those data points are to that line of best fit. The closer to 0 that that correlation coefficient is, the more spread out you'll see them. If this is a line of best fit, something that has a very low correlation coefficient, you might see points kind of spread out all the way around. In this case, it's not a low correlation coefficient, but it's also not a perfect correlation, right? We don't see all the points along that line that I drew. So it cannot be -1. 1 would be they all line up on a straight line. In this case, that's not what we have, so it must be 3. Okay, we just determined, is the correlation positive or negative, and that narrowed it down so we could choose between these two. We know it's not exactly 1 because they don't all fit perfectly along that line. Okay, let's go to question 12. So Keith determines the zeros of the function f of x to be -6 and 5. What could be Keith's function? Okay, so the zeros basically is what numbers can you plug in to these x values to make these equations equal to 0. Okay, so we can figure that out very easily. All right, so let's take -6. They told us is one of the zeros. So that means when we plug in 6 to these functions, the function must equal to 0. So let's start with number 1. If we plug in -6 to x, this will be 0, right? This part will be 0. Anything times 0 is 0. Okay, so far that works. So far, option 1 might work. Okay, let's look at option 2. If we plug in -6, this will give us -12. Okay, that's definitely not going to work. If we plug in -6 here, it'll give us -1. That's not equal to 0. Okay, basically, if this term has a x minus 6, it will not work. So that's 2 is out and 4 is out. Okay, it's either 1 or 3. Okay, now let's look at 5. That's what's going to tell us which one is the answer. Okay, if we plug in 5 to option 1, this gives us 10 here. If we plug in 5 here, it'll give us 11. 10 times 11 is not 0. So that's out. Now let's just prove it with option 3. Okay, if we plug in 5 here, this is going to be 5 minus 5. This will be 0. It doesn't matter what this is. The equation will be equal to 0. Okay, that works. And then same thing with -6. -6 plus 6 will give us 0. It does not matter what this is. Anything times 0 is 0. So that works with both of those. So this would be 3 for 12. Okay, let's look at 13. Okay, so we have a bunch of letters, and those are equal to a couple different expressions here. So it's asking which expression results in a rational number. Okay, so let's determine first, individually, are these irrational or rational? Okay, square root of 2. Square root of 2, if we plug it into the calculator, it'll give us a infinite decimal. So it'll give us a number that does not terminate anywhere, it just has a bunch of numbers that are infinite. So this is irrational. That's like an example of an irrational number, something that has an infinite decimal. Okay, m 3 times square root of 3. Square root of 3 again is one of those infinite decimals, so again that will also be irrational. Okay, if you want to check for yourself, plug these into a calculator and see what it gives you. If it gives you a long string of decimals, that's irrational. Okay, let's look at n. Square root of 16, you can plug it into the calculator, but that's equal to 4, so that is rational. Square root of 9, same thing, that's equal to 3, so that is rational. Okay, so we know L and M are both irrational, and N and P are both rational. Okay, and these are all sums, so we're adding two of these here. Okay, so basically if you add an irrational number plus an irrational number, you will get an irrational number. And if you add a rational and an irrational number, you will again get an irrational number. Okay, so we're looking for which one of these sums does not have L or M in it, because again, irrational plus irrational gives us irrational, and rational plus irrational gives us irrational. So it cannot have either L or M in it. If not, it will be irrational. Okay, L plus M, both irrational. Okay, that does not work. Number 2, M is irrational, N is rational. Again, this will be irrational. 3, N plus P, that's just 4 plus 3 gives us 7. That's a rational number, so that's definitely going to be it. And let's just look at number 4. P is rational and L is irrational, so that's not going to work. Okay. All right, let's go to question 14. So it asks which system of equations has the same solution as the system below. Okay, so we're going to try to use the same idea as we use in elimination when we're actually solving systems of equations. So if you remember elimination, basically what we're trying to do is we're trying to multiply one of these equations by some number so that we can subtract out one of the terms. So let me show you what I mean by that. So let's say I had this here. I want to multiply one of these two equations by something so that I can subtract the two and cross out one of the terms. So what I see straight away here is if I multiply this by -2, what do I get? I'll get -6x plus 2y equals -8, right? And then we're left, this becomes this, and then we'll rewrite this down here. So we have 2x plus 2y equals 16. Okay, and now when we subtract these terms, we subtract this term down here from the term above. That leaves us with -6x minus 2x, which would be -8x. 2y minus 2y just leaves us with 0, so we won't write anything there. And then -8 minus 16 will leave us with 24. Okay, and then we just divide by -8, and that should give us what x is equal to. All right, but we're not actually doing that here. We just want to use this idea that I showed right here. Right here in this step, I multiplied this equation by -2 to get this new equation. I didn't actually change the equation. It still has the same solutions. I just made it more convenient. So the question is here, can we match up these two terms with any of these options? Okay, so let's put it all together. All right, let's look at the first term. So we have 2x plus 2y equals 16. Okay, we see that here. We see that here. Here we do not see that, and here we do not see that. That does not mean those are not the right answers. It just means that we have to see how we can possibly get there. Okay, so if we multiply this whole thing by 1/2, we would actually get x, right? If we distribute this all the way through, we would get x plus y is equal to 8, right? So this term right here should be x plus y equals 8. It's not, right? This is wrong, so this expression is out. Okay, so now how could we get this one right here? All right, so if we multiply this term, this equation by 3, we would get 6x plus 6y is equal to 16 times 3, which is 48. So that works. That still works, right? This could still possibly be it. We've eliminated one, but not all of the answer choices. Okay, so this could still be it, right? Okay, so now let's look at the second equation down here. Okay, do we see this anywhere? So it's not here, it's not here. We do see it right here, but we already eliminated that answer choice, and we don't see it here. Okay, so this was modified somehow. Okay, so let's start with the first option. What could we do to get to this point? Well, we could maybe multiply by 2, right? If we distribute this out to each of them, what would that give us? It would give us 6x minus 2y equals 8. Is that what we see here? We have 6x minus 2y equals 4. Okay, that does not work. Okay, we should have 6x minus 2y equals 8, and we don't see that here, so that option is out. Okay, good. We've eliminated 2 options so far. All right, let me just clean this up. Okay, now let's keep going. We're still looking at this equation here. All right, let's look at option 2. Okay, so again, if we multiply this by 2, what do we get? We get 6x minus 2y is equal to 8, and that's what we see here. So this looks like it's the right answer. All right, so let's just double check and look at 4 to see, is it in fact the right answer? Okay, so same thing. If we multiply this by 2, we would get 6x minus 2y equals 8. What do we see here? 6x, but we have instead a 2, or a positive 2y. So that would make this one wrong. We cannot get to this, so 2 is the correct answer. Okay, let's go and look at question 15. All right, so question 15 says the table below represents the function f. Okay, so we have this table, we have and we have x and f of x values. Okay, so the equation that represents the function is which of these? Okay, so one way that you could do this is you can plug each of these equations into your calculator and check the table to see which one has these numbers in it, right? If it has all the numbers in it, then that is your correct answer. But we actually don't need the calculator here, and it's actually quicker and easier without the calculator. So how do we do it? Okay, so we take these individually. So we look, okay, if I plug in 3 for x, I should get 9 in each of these equations, okay? All right, let's look at the first one. 3, if I plug in x, if I plug in 3 for x for 3 raised to the x, that's 3 raised to the third power. That would give us 27 if x was equal to 3. So that does not work because it should be 9. Okay, so 1 is already out. Okay, let's look at option 2. If I plug in 3 for x, what do I get? 3 times 3 is equal to 9. That works fine. Okay, it doesn't mean it's the right answer. It just means we haven't eliminated it yet. Okay, so let's look at option 3. So 2 raised to the third power, right? We're still plugging in 3 for x. So 2 raised to the third power is 8 plus 1 gives us 9. Okay, that works there. Okay, so we have already 2 that work. We have to check one more. But first, let's check answer choice 4. Okay, so if we plug in 3 for x, it gives us 2 times 3 plus 3, that's 6 plus 3 gives us 9. Okay, so that still works. Okay, so these 3 we could not eliminate, but we have 1 is out. All right, let's go on to the next one. So now let's plug in 4 for each of these, and if it gives us 17, it works. If it doesn't, we have to keep going. Okay, so first for option 2, 3, we're plugging in 4 this time. 3 times 4 should give us 12, so that does not work, right? It should give us 16. All right, so 1 and 2 are out. All right, let's look at 3. So here, again, we're plugging in 4 for x. So 2 raised to the 4th power plus 1 gives us 1. So 2 raised to the 4th power is 16 plus 1 gives us 17. So that one still works. Okay, it could be 3, but we have to check 4. Okay, so option 4, again, we're plugging in 4. So 2 times 4 plus 3. This gives us 8 here. Plus 3 is equal to 11. That does not work for option 4, so it has to be option 3. Okay, so here the quickest thing to do was actually to plug in and check. They're relatively simple equations, so it wasn't very difficult to plug in x and check to see if it gave us what the f of x value is. Okay, if you found this video helpful, leave us a like, subscribe, and follow us for more Regents exam videos for both math and science.